Okay, so I'm looking at CC2, 7th grade math, section 2.1.1, number 2-11, okay? Probability. So Nicole has a machine that will produce a number from 1 through 50. So random number generator. She just basically just pushes a button and poof, a number between 1 and 50 pops up. It could be 1, it could be 2, could be 3, could be 4, could be 5, could be 6, blah, 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 all the way to could be 50, right? Any one of those numbers pop up. So it says explore by highlighting the numbers on the E tool. So there's an E tool that'll help you. It lists all the numbers and you can highlight in order to count. So I'm going to just do this with paper though at this point, not through the E tool. So the question is, if she pushes the button, what is? What is what? So A, what is A asking? A is asking, what is the probability? Remember, when you see P with parentheses, that means what is the probability of, and then of what? Of, in this case, getting a multiple of 10, right? So that's what this, when you see this notation, P with parentheses, something inside, it's saying what is the probability of getting a multiple of 10. That's what it's referring to. So when we think about all the numbers, right? If I was to list all the numbers out, and I won't do that, but if you get all the numbers listed out, 11, 12, 13, all the way, and then 21, 22, 23, and then all the way, so on and so forth. All of these numbers down to 50, right? All of them out. And you look to see what numbers are multiples of 10. How many? Well, I've got these actually written. 10, 20, 30, 40 are multiples of 10. So how many of them are there? There's 5. Remember that probability, okay, this is the key thing. Probability is always the desired outcomes, right? The desired outcomes over the total outcomes. So in this case, my desired outcome is multiples of 10. Multiples of 10. That's my desired. How many are there? That's my desired outcome. There's 5 multiples of 10. And then probability, so it's desired outcomes over total outcomes. What are the total? How many possible total numbers are there? Well, there's 50. So my probability for this problem would be 5 over 50. And then you can always simplify probabilities just like fractions. And so this divides 5 top and bottom to be 1/10. So 1/10 or 5/50. That's the probability of getting a 10. Okay, so hopefully that makes sense. So look at B now. B says, what's the probability of not, so P of not 100? Okay, wait, not 100. Is 100 a possibility? No, there's no way you're going to get 100. The only possibilities are the numbers 1 through 50. So what's the probability of not 100? That would be 50 over 50, right? 50 over 50 is the probability of not 100. Oops. 50 over 50 is not 100. So that being said, 50 over 50 is the same thing as 1. So the probability of not 100 is 50 over 50 because there's 50 desired over 50 total, and that would be or 1. Okay? So then let's look at C. C, get to C. C is not a multiple of 4. So I'm going to go down here. So I want to write this out. So I'm going to looking for the probability of not a multiple of 4. So which numbers are multiples of 4? what are the multiples of 4? So I'll just list them, right? If I can look at the number chart and figure that out, but you've got 4, 8, 12, 16, 20, 24, 28, 32. I'm just going to list them all out. 32, 36, 40, 44, 48, and that's it. So those are my multiples of 4 within 1 through 50. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12. So there's 12 multiples of 4. So if I was saying get rid of the not, it would be 12 over 50, right? So if I were going to actually say what are the probability of getting a multiple of 4, that would be 12 over 50. But now I want to know not multiple of 4. So if there's 12 possibilities that are multiples of 4, the not would be the opposite. That would be the 38, the other amount. So in this case, 38 out of 50 is the not multiples of 4, since 12 out of 50 is the multiples of 4, right? So it's the other numbers. And then if we're going to simplify that, I think it divides by 2, top and bottom, and you can say that would be 19 over 25 would be the other possible answer. Okay. All right, last one. I'm running out of room on my paper, so let me get a new paper out. Last one would be D. So what is the probability of a one-digit number? Probability of a one-digit number. Well, how many one-digit numbers are between 1 and 50, right? Single-digit numbers. That's right. There's only going to be 9. It's 1, 2, 3. So, right, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are only single digits. There's 9 of them. So it's 9 out of 50. The desired is 9. The total is 50. Okay, there you go.